Welcome to RN Edge Academy channel. Find the roots of the following quadratic equations if they exist by the method of completing the square. First step is to check whether the coefficient of x square is 1. If not, divide the equation by the coefficient of x square. So in this case, we will divide the equation throughout by 2. 2 by 2 is 1 minus 7 by 2x plus 3 by 2 is equal to 0 divided by 2 is 0. Step 2 is to transpose the constant to right side. Step 3 is to multiply the coefficient of x by 1 by 2. So 7 by 2 multiply 1 by 2 is 7 multiply 1 is 7. 2 multiply 2 is 4. Now add the square of 7 by 4 to both sides. 1x square minus 7 by 2x plus 7 by 4 whole square equal to minus 3 by 2 plus 7 by 4 whole square. Now this is the expanded form of a minus b whole square. Step 4 is to simplify it. X minus 7 by 4 whole square equal to minus 3 by 2 plus 49 by 16. I'll take the LCM of 2 and 16, which is 16. So minus 3 multiply 8 plus 49. X minus 7 by 4 whole square is 3 multiply 8 is minus 24 plus 49 divided by 16. Minus 24 plus 49 is 25 divided by 16 is equal to x minus 7 by 4 whole square. Now square root both sides of equation. That's our step number 6. Square root can also be expressed as 1 by 2. Do not forget to add plus and minus sign because a quadratic equation always has two roots. Two multiply 1 by 2 is 1 plus minus 25 is 5 square, 16 is 4 square raised to the power 1 by 2 plus minus 5 by 4 whole square raised to the power 1 by 2, which is equal to x minus 7 by 4. X minus 7 by 4 is equal to plus minus 5 by 4. So x minus 7 by 4 is equal to plus 5 by 4. X minus 7 by 4 is equal to minus 5 by 4. Now transpose minus 7 by 4 to right side. Equal to 12 by 4, which is equal to 3. Minus 5 by 4 transpose minus 7 by 4 to right side plus 7 by 4. Minus 5 by 4 plus 7 by 4 is 2 by 4, which is equal to 1 by 2. So roots of given quadratic equation are 3 and 1 by 2. Try to follow the steps. Step number 1 is to check whether the coefficient of x square is 1 or not. If it is not, then divide the entire equation by the coefficient of x square. In this case, divided by 2. 2 by 2 is 1, 1x square plus x by 2 minus 4 by 2 is. Step 2 is to transpose the constant to right side. Constant is term without x or variable. 1x square plus x by 2 is equal to 2. Step 3 is to multiply the coefficient of x by 1 by 2. Coefficient of x is 1 by 2. X by 2 can also be expressed as x multiply 1 by 2. So coefficient of x is 1 by 2. Now multiply 1 by 2 by 1 by 2. It is equal to 1 multiply 1 is 1. 2 multiply 2 is 4. 1 by 4. Now add the square of 1 by 4 to both sides of equation. 1x square plus x by 2 plus 1 by 4 whole square equal to 2 plus 1 by 4 whole square. This is the expanded form of a plus b whole square. So write it down, x sine plus 1 by 4 whole square is equal to 2 plus 1 by 16. 2 by 1 multiply by 16 plus 1 by 16, it's equal to x plus 1 by 4 whole square is equal to 2 multiply 16 is 32, 1 multiply 16 is 16 plus 1 by 16 equal to 33 by 16. Step 5, square root both sides of equation. Square root can also be expressed as 1 by 2. Now 2 multiply 1 by 2 is 1. Remaining is x plus 1 by 4. The plus minus under root of 33 divided by 4. Because 16 is square root of 4. So x plus 1 by 4 is equal to plus minus root 33 by 4. X plus 1 by 4 is equal to plus root 33 by 4. X plus 1 by 4 is equal to minus root 33 by 4. Transpose 1 by 4 to right side or isolate x to find its value. Minus 1 by 4. So it's equivalent to root 33 minus 1 by 4. Similarly, transpose 1 by 4 to right side. X is equals to minus root 33 by 4 minus 1 by 4, which is equivalent to minus root 33 minus 1 divided by 4. So roots of 2x square plus x minus 4 equal to 0 are root 33 minus 1 by 4 and minus root 33 minus 1 by 4. Well done. Let's move to third part. Remember step number 1? Step number 1 is to check whether the coefficient of x square is 1 or not. If it is not, then divide the entire equation by its coefficient is equal to 0 by 4. 4 divided by 4 is 1 plus 4 root 3 divided by 4 is root 3x plus 3 by 4 is equal to 0. 0 divided by 4 is 0. Step 2 is to transpose the coefficient to right side. Step 3 is to multiply the coefficient of x by 1 by 2. It's equal to root 3 by 2. Now add the square of root 3 by 2 to both sides of the equation. So x square plus root 3x plus root 3 by 2 whole square minus 3 by 4 plus root 3 by 2 whole square. Step 4 is to simplify. X plus root 3 by 2 whole square is equal to minus 3 by 4 plus root 3 square is 3 and 2 square is 4. Minus 3 by 4 plus 3 by 4 is equal to 0. So x plus root 3 by 2 whole square is equal to 0. What was the next step? To square root both sides of the equation. Now, under root of 0 or square root of 0 is plus, minus 0 does not exist, equal to x plus root 3 by 2. Now transpose root 3 by 2 to right side. So x is equals to minus root 3 by 2. Minus root 3 by 2 and minus root 3 by 2. Well done. Fourth part is 2x square plus x plus 4 is equal to 0. Now what was the step 1? We will divide the entire equation by coefficient of x square, that is 2. 2 divided by 2 is x square plus x by 2 plus 2 is equal to 0 divided by 2 is 0. Step 2 is to transpose 2 to right side of the equation. Step 3 is to multiply the coefficient of x by 1 by 2. So x by 2 can be expressed as x multiply 1 by 2. So what is the coefficient of x? Exactly 1 by 2. 1 by 2 multiply 1 by 2 is 1 by 4. 1 multiply 1 is 1, 2 multiply 2 is 4. Now add the square of 1 by 4 to both sides of equation. Simplify it. X plus 1 by 4 whole square is equal to minus 2 plus 1 by 16. Let's solve it. Take the LCM of 1 and 16 is equal to x plus 1 by 4 whole square is equal to minus 2 multiply 16 is minus 32. 1 multiply 16 is 16 plus 1 by 16. The minus 32 plus 1 is minus 31 divided by 16 is equal to x plus 1 by 4 whole square. Since minus 31 by 16 is less than 0 and x plus 1 by 4 whole square cannot be negative for any real value of x. Thus, the roots do not exist. Real roots do not exist. Now try to understand x plus 1 by 4 whole square. What was our next step? Next step is to square root both sides of the equation. So x plus 1 by 4 square raised to the power 1 by 2 minus 31 by 16 under root. And this term will not give a real number. Thus, the real roots of the equation do not exist. So this brings us to an end of question 1 of exercise 4.2.